talk about writing slope-intercept equations given a graph in which we can find the slope and the y-intercept. First of all, let's practice finding a couple of slopes. In this case, when we're given two ordered pairs like this, then we know that we're going to be using something like the slope formula. So I'm going to go ahead and set this up. I'm going to have the first one, I'm going to take the second y value, which is -1, subtract the first y value, which is 3, and then all of that will go on top because that's the change in y. And then the change in x is going to be the second x value, subtract the first x value, which happens to be in -5. So let's go ahead and figure this out. -1 subtract 3 is -4. And 5 subtract -5 is 5 plus 5, which is just 10. Now, in these problems that we're going to do today, where you're going to be writing the equation, we want you to simplify the slope. So -4/10 would equal -2/5. That would be simplified all the way to lowest terms, but still in fraction form. All right, let's take a look at part B. We've got 2 subtract -1. All of that's on top, and then on the bottom we have -4 subtract the first x value, which is -3. So 2 subtract -1 is the same as 2 plus 1. So that just becomes a big plus sign, and so does this. So 2 plus 1 is 3. And -4 plus 3 is -1. So our slope on this one is -3/1. And oftentimes when you see it in an equation, they just write -3. But you know this is what it means. All right. So just to kind of review, to write an equation of the line given a graph of or a slope and a y-intercept, we just write it in this form, and we realize that we'll have a y, an equal sign, then a number here that represents the slope, then the x variable, a plus or minus sign, and then another number in this position that represents where this line crosses the y-axis, which is called the y-intercept, and we're just using the y value there. So the equations we will be writing from our graphs will be in the slope-intercept form that we've just been describing. So let's take a look. All we need to do is find the slope and the y-intercept of the graphed line and then write the equation. It's that easy. It's really that easy. Okay, so in this particular case, we got a slope of 1/2, y-intercept of 2. So let's write the equation. Y equals 1/2 x plus 2. There's the b, and there's the m that we were talking about, and there's b, or the y-intercept. All right, let's try it with another slope. So here's another slope, y equals -5/4. So let's write that down. Y equals, and m in this case is -5/4. Then we write down the x value. And then we notice that our y-intercept is a negative number, so -2. So instead of +2, we're going to put -2. And that's because we had a y-intercept of -2. So there's our equation. That is really easy, isn't it? Okay, let's try another one. We have a slope of 2/3 and a y-intercept of 0. That's the first time we've seen a y-intercept of 0 on this assignment. So let's see how that's going to work. So if we write or put our slope in where m is at, right there, let's actually put it down here on the bottom. Y equals, our slope is 2/3. And then because there's no y-intercept, we have a 0 here. That's what the equation is going to look like. If there was something other than 0, we would have plus or minus whatever that number happened to be. But since we don't, we just end up with y equals 2/3 x. All right, here's in this case we have an actual graph. So we've got to start out by finding the slope. So the slope in this case, to go from this point to this point, I have to go down 2. So down 2 and over 1, 2, 3, 4. All right, so our slope is negative 2/4. So now that we know what the slope is, negative 2/4, we can actually simplify it. Like we said, on this assignment, we want these fractions simplified. So we have a slope of negative 1/2. And then we notice that when this line crosses the y-axis right here at a y value of 3. So that's the y-intercept. So when we write the equation, we get y equals negative 1/2 x plus 3. Let's try another one like that, where we have to do a little bit more of the work. Now this particular line goes up through here, but I'm having a little bit of a hard time seeing a couple of identifiable points on there. But I notice right there at the y-axis, there's a good y-intercept point right there. And as I come up the line, keep going, finally I get to right here. I can see where this line crosses another easily identifiable point of 5, 2. All right, so now I'm ready. So I know that my y-intercept right here is negative 1. Let's find the slope. So we have to go up 1, 2, 3, up 3 to get to our new point, and then we have to turn and go over 1, 2, 3, 4, 5. So there is our slope. And then we write our equation in that y equals mx plus b form. So we will end up with y equals 3/5 x subtract 1. And that's our slope-intercept form of that equation for that line. This is pretty powerful. Let's try this line. So we've got a line here, and I've already marked a couple of known points here. It was similar to the one we saw just a few moments ago. So if you look, here's a point and here's a point. So to be able to get from one point to the other, let's do our little counting. So we go up 1, 2, 3. So up 3, and then over 1, 2, 3, 4, 5. So we went over 5. And our y-intercept was negative 1. So our equation is y equals negative, or positive, 3/5 x minus 1. So there's that particular problem. All right, how about this one? We got a slope kind of coming downward, so we're going to have a negative slope. So right away, I'm going to put a negative sign there because I know it's going to be a negative number. As I look at my line really quick, I notice that there's my y-intercept. The y-intercept is positive 2. So all I need to do is find another point along this line that will help me get my slope. And I notice right there is a good crossing point right there on the y or x-axis. So to go from the left point to the right point, I go down 2. So down 2 and over 1, 2, 3, over 3 like that. So then my equation would be y equals negative 2/3 x plus 2. And I've written the equation for that line. All right, yet another one. We've got a couple more examples here. So here's my y-intercept. My y-intercept b is 4. Now I need to find my slope. As I look at this particular line, it comes down and it crosses right here, crosses right here. So this is going to be pretty easy. That means I just go down 1 over 2. So my slope is down 1 over 2. So I have a slope of negative 1/2. So let's write the equation. Y equals negative 1/2 x plus 4. So there's the equation of line for that particular problem. So we've got a couple of different kind of looking lines here now. Let's take a look at these. Here I have a flat line, which means it has a 0 slope. So when I write this down, I'm going to have y equals 0x. And then my y-intercept happens to be 1, 2, 3 at -3. And anything times 0 is just 0, so we can just kind of cancel this out. And we're just left with a y equals -3. So this is the equation that you have to demonstrate this particular graphed line. We got one more special case, and that's what if I have a vertical line that goes straight up and down? Well, if you notice, it doesn't ever cross the y-axis because it never even gets close. It's always crossing the x-axis at some point. So the y-intercept is just completely missing, all right? So it's gone. And it has an undefined slope, meaning it's going straight up and down. So that means that the change in x is 0, right? But the change in y could be anything because you've got this line going straight up and down. So the way we illustrate this particular situation is we just say, okay, where does this cross the x-axis? And it crosses at 8. So at x equals 8, this is where it crosses the x-axis. And then it turns out that every other point along this line also has an x value of 8. And some other, so that's, or some other y value like 8, 1, 8, 2, 8, 3, so on and so forth. So that's how you would do one that goes straight up and down. So we have an ALEKS assignment where you get to practice doing a few of those kind of problems. So good luck and thank you very much.